Okay, I decided to make part one, or maybe, yeah, part one of maybe 2 or 3 videos to get you guys going on this answer key in case you are at a loss of how to do some of these problems because it's been a minute. So I'm going to work out each problem. I suggest that you listen to what I'm saying, not just copy down the answers, okay? So first page is exponents. If you remember when we are multiplying terms with the same base, we add these values. So it's like saying a to the negative 9 plus 3. So you end up with a to the negative 6. And if you recall, we can't have a negative exponent, so our solution for that is to put the value in the denominator, make it positive, and put a 1 in the numerator, right? We cannot have a negative exponent. Okay, for number 2, this is like saying w to the 6 times itself 7 times, so the shortcut is to multiply. So we have 6 times 7, so your answer would be w to the 42nd power. Number 3, we have 3 terms that are being multiplied, so we do the 3 times the 4 times the 2, and we get 24, and then we add the exponents, and remember there's a secret 1 here, so we would have 24x to the 6th would be the answer there. Number 4 is similar, except we have to distribute these from the outside in. So now I have 4 squared r to the 4th times 2 squared r to the 6th. So that's like saying 16r to the 4th times 4r to the 6th. 16 times 4 is 64. R to the 4th times r to the 6th. Remember, we're going to add those, so I have r to the 10th. This one is division. Remember, with division, we subtract. So we would do 5 minus 4 equals 1, so we have m. And you can put a 1 there if you want, you don't have to. 3 minus the 1 that's hiding here is 2, so that would be n squared. And then 2 minus the 1 here is also just 1. So that would be your answer, m n squared p. And again, you can put those 1s there if you want to, you don't have to. All right, we're getting slightly more complex. Oh.
Good morning, Westers. Welcome to Friday, our second to last Friday of this school year. I want to start off by thanking DJ Jazzy Dan Z for taking over the last 2 weeks. I heard he did a phenomenal job at Name That Tune. Today, we're looking for caller number 9 at 18107.
Sorry, guys.
Get those
Just a
fingers
second.
stretched out. Put those phones away. No cheating, please. I'm caller number 9 at 18107. Good luck, everybody. We're looking for the title of the song and the artist.
Okay, you guys, I really want to win. Okay, I know it's the Beatles. Why can't I think of the title? Someone's going to win and I'm going to be mad because I really want Starbucks. That's what you win. You get Starbucks. Oh, this makes me sad. We have to wait to see who wins. Hold on, guys. You're being good and patient. Appreciate it. The anticipation, I'm sure, is killing you. Sorry, this is taking way longer than it should. I guess nobody knows the name of the song. This is like triple the amount of time it normally takes, guys. Sorry. It's probably called instant karma. That's what it's going to be called.
We have a winner. Today's winner is Meg Dombrowski. Congratulations, Meg. And of course, the song title is Instant Karma by none other than John Lennon.
Good times.
Have a great day, West. Happy Teacher Appreciation Week.
Okay.
Let's get this done.
All right, here we go. Back to our math. So we're getting more complex. We have to distribute this 3 to every term inside, in the numerator and the denominator. So I'm going to end up with 4 to the 3rd power, u to the 3rd power, v to the 6th power, because remember, this 1 times the 3, over 3 to the 3rd power, u to the 6th power, v to the 6th power. Okay, so what do I do with this? Well, I'm going to find out, well, what's 4 to the 3rd power? Well, that's 64. And then 3 to the 3rd power is 27. I can't do anything with those. Nothing can be simplified. So those numbers are pretty much set in stone. Now, when I subtract 3 minus 6, I get u to the negative 3rd. And then 6 minus 6 is 0. Anything to the 0 power is 1. So these are just gone. But then I have this negative here. I can't have that there. So this has to be moved down to the denominator. So my final answer is going to be 64 over 27 u to the 3rd, because I had to shift that down. Okay. Number 7, negative 3 minus 0 is going to be negative 3. And again, we can't have that negative, so our final answer is 1 over d to the 3rd, because again, we shift it to the denominator. And then this last one, I see right here that these can be simplified. So I'm going to go ahead and do that. Make this a 2 and this a 1. Okay. So now I'm going to distribute all of these values, but I'm going to keep this as a 2. So 2 to the 3rd power, r to the 15th power, t to the 21st power, over, 1 to the 3rd power is nothing, right? R to the 27th power, and t to the 12th power. So now I have, that's a really weird 2, isn't it? What was I doing there? Okay. So now when I simplify these, I'm going to get 8. 15 minus 27 is negative 12, so r to the negative 12. And then 21 minus 12 is positive 9. So I have this number. I guess technically it's all over 1, because there's nothing else there. It's just a placeholder. But I can't leave this here. Remember, last step is move the negatives. So I'm going to have 8 t to the 9th, those stay in the numerator, over r to the 12th. That would be my final answer there. Okay, next page. Sketch this graph. Okay, remember the best thing to do for functions is to make a t-chart. So I'm going to make x's and y's. And then for the x's, we've talked about using negative 2, negative 1, 0, 1, and 2. Okay, those are just solid numbers to give us a good idea of what's happening. So when I put this negative 2 in for x, I get negative 1/4. Excuse me. I get 1/4. And then when I put the negative 1 in, I get 1/2. And then I get 1. Then I get 2. And then I get 4. So when I graph these, I have negative 2, and then I have a teeny tiny little 1/4. And then negative 1, 1/2, 0, 1, 1, 2, 2, and 4. And that's when you can see that it is exponential because it's curved, right? It has an exponential. Yeah, you're with me. Okay, polygons, everybody's favorite. When you are adding polygons, you're literally just looking for common exponents, and if they have a common exponent, you can combine them. If they don't, you just bring them down and leave them where they are. So because I have 3x to the 5th and 4x to the 5th, I now have 7x to the 5th. Excuse me. I don't know why I wrote 4. Because I have 7 of those x's to the 5th. I don't have anything that matches 10x to the 3rd, so that's just going to come down the way it is. Nothing to combine there. I don't have anything that combines with negative 3x squared, so again, that just comes down. And then the negative 5 plus the 13 is going to give me a positive 8. So I just looked for like terms and combined them. Subtraction is a little bit different, right? And that main reason is because I have to distribute this secret negative 1. If you remember, we distribute the negative 1 and then it turns into an addition problem. So I'm going to have 3x to the 5th plus 10x to the 3rd minus 5 minus 4x to the 5th plus 3x squared plus 13. Okay, so I'm literally just distributing that value. So when I combine these this time, I get 3 minus 4 is negative 1. So I'm going to have negative x to the 5th. You can put a 1 there if you want. You don't have to. And then 10x to the 3rd has nothing to combine with, so I'm going to have that 10x to the 3rd. 3x squared has nothing to combine with. And then the negative 5 plus the 13 gives me that positive 8. So it changed mostly the first and the third. Like, I don't know if you guys noticed, these were pretty much the same thing, just one was adding and one was subtracting. Okay, moving right along to number 12. We're gonna FOIL everybody's favorite, right? First, outer, inner, last. So the first terms together are gonna give me 25y squared. Outer is gonna give me negative 20yz. Inner is gonna be positive 20yz. And then last is going to be negative 16z squared. So when we combine these cancel each other out, right? Negative 20 plus 20, those are gone. So my answer is 25y squared minus 16z squared. That's my final answer because these canceled out. For this next one, when I see a square, that means I'm literally just doing 5a plus 3 times 5a plus 3. So again, when I FOIL, my first is going to give me, 25a squared. Outer is going to give me 15a. Inner's also going to give me 15a. And last is going to give me 9. So the difference here is that these don't cancel out. So that becomes part of my final product. So I'm going to have 25a squared plus 30a plus 9. Okay. Hopefully this is bringing back fond memories. I know you guys love foiling. All right, we'll do a couple factoring and then we'll stop. So factor each polynomial completely. What I'm looking for is the answer to be in two quantities, meaning once you figure out the numbers that work, then you just leave them in the quantities. So this one's easy because my a value is 1, so I can do what times what equals c, and what plus what equals b. And when you do that, you end up with negative 15 times 4 and negative 15 plus 4. So these are going to be my answer, x minus 15 times x plus 4. That's it. You stop right there. We're factoring it. We have our quantities. We don't do anything with these unless it asks us to find the zeros, which is the next section. Okay, number 15 is a little different. We have a greatest common factor. So my greatest common factor happens to be 3. So I'm going to rewrite this as 3, and then 3 times what gives me 3g squared? Well, g squared. 3 times what gives me negative 36g? So that's going to be minus 12g. And then 3 times what gives me 96? Plus 32. So I'm going to save this for the end. This doesn't go away, right? I'm just now going to focus on this, which is nice because I don't have anything greater than 1 for my a value. So what times what equals 32, and what plus what equals negative 12? Negative 8, negative 4. So now I have x minus 8 times x minus 4, but I have to bring this 3 back down, and there's my answer. 3 times the quantity x minus 8 times x minus 4. Number 16, we don't have a b value, right? So it's what times what equals negative 121, and what plus what equals 0, because it needs to cancel out, right? Because we don't have a b value, that means that when it was FOILed, the b's canceled each other out. So we're going to have negative 11 and 11. So then our answers are x minus 11 and x plus 11. And then this one is everybody's favorite, AC method. So I'm going to do the 7 times negative 8 gives me negative 56. So what times what equals negative 56? What plus what equals 1, right? There's that secret 1 right there. So I'm going to have 8 and negative 7, right? So now when I rewrite these quantities, I put this original a value back in. So I'm going to have 7x plus 8 times 7x minus 7. Then I look at these two quantities and I say, hey, which one has a greatest common factor? Well, this one does. So I'm going to have 7x plus 8, and then 7 times the quantity x minus 1, and then I divide by the original a, so those cancel out. So my final answer is 7x plus 8 times x minus 1. And remember, how can you check your work? Well, FOIL it. If I FOIL this, am I going to get what I started with? Well, 7x times x is 7. Oops, these should be x n's. Whatever, they're x's. It's fine. You can have an n, you can have an x. But I should get 7 something squared. Perfect. And then outer is going to be minus 7x. Inner is going to be plus 8x, so that's going to give me the plus 1. And then 8 times negative 1 is negative 8. So again, you can always check your work on those. Okay, we're going to stop right there for today, and I will put together another video for you guys on Monday.